All right, in 12.5, this last lesson in the unit, we're just going to continue on with more rational exponents. It's kind of cumulative and putting everything together that we've looked at. So today you're going to be simplifying these rational exponents, these fractional exponents, putting them in radical form, leaving our answers in radical form without negative exponents, all that stuff. All that stuff is coming together in this one lesson. So one thing I want to just point out, we're going to assume that all the variables are positive, so we don't have to worry about that absolute value rule, where if you take an odd number out of an even index, we don't have to do the absolute value stuff on this assignment. All right, so let's look at number 1. X to the 1/3 power raised to the negative 2. Well, since it's negative, I need to move all of this stuff below. And now it's a positive 2 power. Now I'm going to do the rule where if you have a power raised to a power, we multiply the powers. So it's 1 over x to the 2/3 power. And if I rewrite this, remember that 3 is the root. So it's going to be a cube root of x squared over 1. Now I have to rationalize this. So I know it's going to be a cube root, and it's that funny looking 1. Cube root of what, though? Because we need 3 x's for this x to pop out. So I need one more x here. So now when I multiply, I'm going to have the cube root of x on the top and just an x on the bottom. And now I know I'm finished because there's no radical in the bottom, there's no fractional exponents, there's no negative exponents. We've gone as far as we can go. Let's look at number 2. X to the negative 2/7 power raised to the 2nd power. So I'm going to go ahead and multiply my powers here, get rid of the parentheses, and see what I have. So I'll have x to the negative 4/7 power. Well, it's a negative power, so I need to put it under a 1 to get rid of that negative part. Now let's think about this. It's the 7th root of x with the 4th power on it. Now I can't leave it like that. You can't leave a radical in the denominator, so now I'm going to have to rationalize with the 7th root stuff. So now let's think about this. How many x's do I need for that x to pop out? Well, I have 4 here. That means I need 3 more to make 7. So what I do to the bottom, I got to do to the top. When I multiply, I'm going to have the 7th root of x to the 3rd over x. All right, so that's as far as I can take this question. I've rationalized it, I've taken care of the negative exponents, and we're done. Look at number 3. All right, so I'm going to take all of this and put it under a 1 so that exponent becomes positive. So I have 2x to the 5/3. Now it's raised to the 3rd power. Now we expand those exponents, and we're going to remember that 3rd raising to the 3 goes to everything. It's 2 to the 3rd times x. Now 5/3 times 3 is 15/3, which I hope you catch is really just 5. All right, so if I clean that up, remember 2 times 2 times 2 is 8. X to the 5th, I lean back and look, I don't have any negative exponents. I don't have any fractional exponents. I don't need to rationalize. So this is where this question stops. It's done. Look at number 4. All right, everything's to the 1/2 power, 25x to the negative 12 to the 1/2 power. So let's, if you want to call it that, distribute that power. So I have 25 to the 1/2 power. And then I have x, negative 12 times that 1/2. Think about this. Negative 12 halves is negative 6, right? So if I clean this up, this portion needs to go underneath. This is just a square root. So it's going to be the square root of 25 over x to the 6th. Well, square root of 25 is 5 over x to the 6th. And look, no radicals, no negative exponents, no rationalization needed. We are done with that question. Let's look at the next one. 4 times x to the 2/5 to the negative 2 power. So again, the negative power means I need to put it underneath. So it's going to be the 4 on the top, and then x to the 2/5 power raised to the 2nd power. That power of 2 now became positive. So now let's clean this up. The 4 stays put. I'm going to multiply my powers here. This will give me x to the 4/5 power. So as I rewrite that, it's the 5th root of x to the 4th. All right, And then I need to rationalize that. So I know I'm going to have to multiply by the 5th root of something. Now let's figure out, if there's 4 x's here, I need 5 to pop out. That means I need one more underneath. So when I multiply, give myself just a smidge more base, 4 times the 5th root of x over, and that x will just pop out on the bottom. And this is my final answer. Let's look at number 6. All right, this looks like a big mess, right? X to the 2/5 raised over y to the negative 3/10 to the 20th power. So first thing I want to do is move that negative power up. So I have x to the 2/5, y to the 3/10, all of it to the 20th power. And let's see what happens when we distribute that power, we multiply them. So let's think, this will be x, 2/5 times 20 is 40/5, which reduces to 8. And then y, 3/10 times 20 is 60/10, which is just 6. So look, no radicals, no negative exponents, we're done. All right, let's look at number 7. The first thing I notice is this negative power right here, and I'm going to move that up. So it's going to be y to the 5th times y to the 3rd to the negative 1/2 power. Now, I can combine these two because they're side by side with the same base, so it's y to the 8th to the negative 1/2 power. Now, the negative 1/2 power means I need to put it underneath, right? So it's going to be 1 over y to the 8th to the 1/2 power. And let's see what happens. When we multiply those powers, 8 times 1/2 is y to the 4th. And that's it. That's the end of that question. It's simplified really nicely. There's no radicals. There's no negative exponents. We're good to go. Let's look at number 8. Y over x to the 3rd to the negative 1/2 power. So everything in here is raised to the negative 1/2 power. That means basically I need to distribute that negative 1/2 power, right? So I'm going to have y to the negative 1/2 over 1/2 times 3 would be negative 3/2, right? Now, notice that they're both negative powers. So to get rid of that, I'm just going to move them on the opposite sides of the fraction bar so that y to the 1/2 becomes positive when I move it down. This guy becomes positive when I move it up. You just relocate them and the sign will change. Now let's see what we have. So we have x cubed. We have a square root of x cubed. That's what this translates. Remember, it's the second root over the square root of y. Well, hopefully you know we can't leave it like that. We have to rationalize it. We can't leave that under there. But we need a square root, and we need 2 y's for that to pop out, so we need another y here. So when I multiply, I'm going to end up with the square root of x to the 3rd y over y. Now, am I finished? Stop and think. If it's a square root and I have 3 of them, can't I take 2 out as 1? So I'll have take 2 out. There'll be 1 left over y. So always look back and see if there's any more additional reducing you can do. Let's try a couple more. Let's look at number 9. Okay, looks kind of gnarly, but we can do this. So the first thing I notice, x to the 8th over 75 y to the 10th. So let's reduce these guys by 3. So this becomes a 4 and this becomes a 25. So now I'm going to have 4x to the 8th over 25y to the 10th, all of it to the 1/2 power. So if I distribute that power, remember, 4 to the 1/2, 8 times 1/2 is 4, so this becomes x to the 4th. Then I'll have 25 to the 1/2, and 1/2 times 10 is 5. So this also becomes the square root of 4 over times x to the 4th over the square root of 25 y to the 5th. Well, hopefully you know that 4 is a perfect square and it reduces to 2. So I have 2x to the 4th on the numerator. On the bottom, I'll have 5y to the 5th. And there is my final answer. I've removed all the radicals, all the negative exponents, all the stuff. Now, number 10 is unique in that if you write it out as a cube root of negative 8, we have to think about a number that we can multiply by itself 3 times that gives us a negative 8. Well, we know with 8 We know it's just 2 times 2 times 2. Well, what's it going to require to be negative 8? Well, it requires that it's negative 2's, doesn't it? So in order for this to work, I need to realize that this is negative 2 times negative 2 times negative 2. So what's changing here is I'm just bringing up the fact that this is an odd root right here. And when you have an odd root, sometimes what pops out is a negative number. So keep that in mind. If it's an odd root, it can pop up as a negative if that's what's required to get you back to the original. So keep that in mind. Now, if it's an even root, that doesn't work because the square root of an even number requires I. Odd roots are different, so just keep that in the back of your mind. You will see some of this on your assignment today, and this kind of principle, again, applies when the root or the index number is an odd number. Let me know what questions you have, and we can talk more in class.